So here's an attempt to solve this quartic inequality by completing the square, and we need to see if there's any issues with it. Just note, every single line has if and only if on it. So it's then we can imply it, imply it this way, but we can also imply it the other way. So there must be reversible statements. Okay, so we just need to be careful with that as we go along. We can either work our way down and check it's true and then work our way up, or we can try and do both at the same time, which I'm going to do. Okay, we're starting with this quartic and then we've added 4 to both sides to get this second line. And if you minus 4 from both sides, you would get back to, to the starting point. So this is okay. If we now completed the square, well, actually just factorized here to here, then that's okay. And if you expanded the bracket out, you would get back to x squared minus 2x squared, sorry, x to the 4 minus 2x squared plus 1. So yeah, these work, these are reversible, they work either way. Now for this inequality, okay, let's just say a minute that I had x squared less than 4. Now we could solve that by doing x squared minus 4 less than 0. This would be how I would solve it anyway, factorizing to give x minus 2, x plus 2 is less than 0. Draw a little sketch and see that, yes, it's between minus 2 and 2. So that's all they've done here, but just with x squared minus 1 all squared instead of it being x squared. So there's no problem with that. And if we went the opposite way, then if you have x squared minus 1 is in between those values and you squared it, you would still be less than 4. So yeah, it works either way here as well. Okay, the next one is the slightly problematic one. At least it looks it. So let's try and work this way. Is that okay? Now, if x squared minus 1 is between minus 2 and 2, then it is going to be less than 2 still. And that would still be the case even if it happened to be minus 5 or whatever. But if it's between sorry, it can't be between minus 5 because we know it's between minus 2 and 2. But whatever the value is, it's still going to be less than 2. So that is okay. It's just whether it's reversible. Does it work that way? And it does in this scenario because x squared minus 1 has to be greater or equal to minus 1, which means we know it's going to be greater than 2. If I had like an x here instead, it wouldn't be reversible because x minus 1 is not necessarily greater than minus 2. It's because there's a squared here that we're okay. So it works going top down, like going down, but it also works going up. X squared minus 1 less than 2 does mean that x squared minus 1 is between minus 2 and 2 because this thing here is necessarily greater or equal to minus 1, so it's greater than minus 2. So that, I'm sure that tripped people up when they saw it, but it's actually okay. We can now add 1 to both sides going down, or you can minus 1 to both sides going up. They're reversible, that's absolutely fine. And for the final part, we're solving another quadratic inequality in the same kind of way I did here. It works okay going this way, and it works okay going that way. So it turns out in this scenario that the argument is completely correct. Just make sure you are considering both up and down implies and like the if and only if aspect, and be really careful with this part. Well done.